ஹலோ
சார், நாகராஜன் சார், நல்லா இருக்கீங்களா சார்?
சொல்லுங்க நாகராஜன்.
தெரியுங்களா சார்?
சிஐடி நாகராஜனா?
கரெக்டா கண்டுபிடிச்சிட்டீங்க சார், பரவாயில்லைங்க சார். நல்லா இருக்கீங்களா சார்?
நல்லா இருக்கேன். நீங்க நல்லா இருக்கீங்களா?
நல்லா இருக்குங்க சார்.
எங்க கார்மியா பக்கம் பிரேயருக்கு வருவீங்கன்னு சொன்னீங்க, வரட்டும்.
வரேங்க சார். இந்த ஞாயிற்றுக்கிழமை வரேங்க சார். கண்டிப்பா வரேங்க சார். அங்கிருந்து வந்து நமக்கு கேலண்டர்ல கொடுத்துட்டு போனாங்க சார்.
என்னதுங்க?
கேலண்டர், புது வருஷ கேலண்டர்ல.
ஓ சரி 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 சரி. ஓகே ஓகே. இந்த நம்பர் எப்படி தெரியும் உங்களுக்கு?
சார், நீங்க தமிழ்ல ஒரு தடவை கொடுத்தீங்களே சார்.
சரி சரி. ஓகே ஓகே.
அது அப்படியே சேவ் பண்ணி வச்சிருக்கீங்க சார் நானு.
சரி 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 சரிங்க. சரி. நல்லா இருக்கேன். நீங்க நல்லா இருக்கீங்களா? அங்கதான் சிஐடில தான் இருக்கீங்களா?
ஆமாங்க சார். இன்னைக்கு லீவுங்க சார். மோடி வர்றாருன்னு சொல்லி காலேஜ் லீவ் விட்டாங்க சார்.
அப்படியா? சரி சரி. ஓகே ஓகே.
போஸ்டிங் வேற 12 போஸ்டிங் எடுக்கிறாங்க சார். வாத்தியார் போஸ்டிங் சார்.
எங்கீங்க?
நம்ம பாலிடெக்னிக் தாங்க சார்.
அப்படியா? சரி சரி. ஓகே.
வெள்ளி சனி ஞாயிறு 3 நாள் இன்டர்வியூ நடக்குதுங்க சார்.
ஓஹோ, நம்ம இவரெல்லாம் கலந்துக்கிறாரா? நம்ம ஒரு பேர் என்ன?
ஆமாங்க சார். எல்லாத்துக்கும் டியூட்டிங் சார்.
ஏன்னு?
பாலிடெக்னிக் சார். குலோத்துங்க வாத்தியார், நம்ம லோகநாத் வாத்தியார், தேவராஜ் வாத்தியார், தண்டவாணி வாத்தியாருங்க. எல்லாம் போஸ்டிங் இருக்குதுங்க சார்.
ஆமா 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 ஆமா.
அந்த போஸ்டிங்க்கு 12 பேர் லைப்ரரிக்கு எல்லாமே எடுக்கிறாங்க. கெமிஸ்ட்ரி, பிசிக்ஸ் எல்லாமே எடுக்கிறாங்க சார்.
லைப்ரரிக்கும் எடுக்கிறாங்களா? லைப்ரரிக்கும் எடுக்கிறாங்களா?
ஆமாங்க சார். ஆமாங்க சார்.
ஓஹோ, சரி சரி சரி.
அது உங்களுக்கு
இன்னைக்கு இருந்தா
இல்லைங்க சார். வெள்ளி சனி ஞாயிறு 3 நாள் நடக்குதுங்க சார் இன்டர்வியூ.
நாளையில இருந்தா?
ஆமாங்க சார். ஆமாங்க சார்.
அப்படிங்களா? சரி சரி. ஓகே ஓகே.
உங்களுக்கு தெரியாதுங்களா? பேப்பர்ல இன்விடேஷன் கொடுத்துருந்தாங்க சார்.
அப்படியா? எனக்கு தெரியாது.
அது ஏகப்பட்ட பேர், 150 பேருங்க சார். 12 போஸ்ட்டுக்கு 150 அப்ளிகேஷன் வந்து இறங்கி இருக்குதுங்க. எல்லாம் ரெடி பண்ணிட்டாங்க சார்.
அப்படிங்களா? சரி சரி. ஓகே ஓகே.
எல்லாம் ரெடி பண்ணி கூட எல்லாம் அனுப்பிச்சாச்சுங்க அவங்களுக்கு.
சரி.
ஆமாங்க சார். டோட்டலிங்க லெட்டர் வந்து எல்லாம் போஸ்டிங் வேணும்னு சொல்லி எல்லாம் கால்பர் பண்ணிட்டு.
சரிங்க.
எல்லாம் அனுப்பிச்சு வச்சுங்க சார். எல்லாம் பூரா எழுதிட்டே இருக்குங்க சார்.
எவ்வளோ?
போஸ்ட் தான் எடுத்துக்கிறாங்க சார்.
ஆமா ஆமா. யாருக்கா நம்ம கார்த்தி எல்லாம் அப்ளை பண்ணிருக்காரா?
யாருங்க சார்? நம்ம இவன் கோகுல் சார் எல்லாம் அப்ளை பண்ணிருக்காரு சார்.
யாருங்க?
கோகுல்.
கோகுலா? எனக்கு யாருன்னு தெரியல. மேஸா?
சரிங்க. அதான் புதுசா வந்திருக்காருங்க சார். அவரெல்லாம் அப்ளை பண்ணிருக்காருங்க.
சரிங்க.
அப்புறம் இவங்களுக்கு கேட்டதுக்கே வேண்டாம்ட்டாங்க. சிலபதி மேடம் வேண்டாம்ட்டாங்க.
ஓஹோ, சரி சரி.
ஆமாங்க சார்.
யாரு இவங்க எல்லாம் போட்டிருக்காங்களா?
யாருங்க சார்?
அந்த கவிதா மேடம் எல்லாம்?
கவிதா மேடம் இல்லைங்க சார். அவங்க ஏன் போட்டு சொல்லிட்டாங்க. ஒரு 12 வருஷம் நிப்பாட்டிட்டாங்க சார். மேடம் வந்தோம்னீங்க.
அப்படியா? கவிதா மேடத்தை அவங்களே நிறுத்திட்டாங்களா?
ஆமாங்க சார். ரமேஷ், ஆட்டோமொபைல் ரமேஷ் இருந்தாருங்க.
ஆமாங்க.
அவரு, அப்புறம் ஸ்ரீவித்யா, அப்புறம் நம்ம கவிதா மேடம், அப்புறம் இவருங்க நம்ம ஹெச்ஓடி இருந்தாருங்க கம்ப்யூட்டர்ல. அவங்க
கம்ப்யூட்டர்ல யாரு ஹெச்ஓடியா இருந்தா?
அதே மேடம் அவங்க ஐடியா இருப்பாங்க. பேர் நல்லா கலைவாணி மேடம் சார்.
ஓஹோ, சரி சரி.
எல்லாத்தையும் நிப்பாட்டிட்டாங்க சார்.
அப்படிங்களா? சரி சரி. இப்ப இந்த கொரோனா டைம்லயா?
இல்ல, அதுக்கு முன்னாடியே மேடம் வந்தோம்னேங்க சார்.
ஓஹோ, சரி 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 சரி.
12 பேர்த்தையும் என்னமோ நிப்பாட்டிட்டாங்க சார் எல்லாம்.
சரி 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 சரி. எனக்கு தெரியாது.
ஆமாங்க சார்.
சரி சார். ஓகே. நான் அப்புறம்
கூப்பிடுறேங்க சார். காரியம் வந்து கூப்பிடுறேன்.
கூப்பிடுங்க. ஒன்றும் பிரச்சனை இல்லை. சரி. நானு இப்போ இந்த இது என்னது இது பண்ணிட்டு இருக்கேன். கிளாஸ் எடுத்துட்டு இருக்கேன். நான் பர்ஃபார்ம் பண்ணுறேன். சரி சரி. ஓகே நாகராஜ். ஓகே நாகராஜ். Hello students. Hello.
Yes sir.
Yes sir. Good afternoon. Okay. I'll have to wait. Okay. Students, today we are going to see about the reactor design. Okay, then I will give you some introduction about the reactor design. Then after that, we will see how to proceed further. And then I will share the protocol, the procedure, okay, how to simulate the reactor design step by step. Okay, I'll have to wait for some time. Yeah. Hello, students, can you able to hear my voice? Hello?
Yes, sir.
Okay, wait for some time. Okay.
சார் அன்னைக்கு நீங்க கூப்பிட்டப்ப கொஞ்சம் அட்டன் பண்ண முடியாத சூழ்நிலை. திரும்ப நான் வந்து 2-3 தடவை உங்களுக்கு ட்ரை பண்றப்ப நீங்க பிஸியாவே இருந்தீங்க.
அப்படிங்களா?
நேற்று நைட் கூட உங்களுக்கு கூப்பிட்டேன். ஒரு 7 மணி இருக்கும். ஆனா உங்க கால் வந்து பிஸி இருந்தது. 7 இருக்கும். அந்த டைம்ல 7:7
நேற்று எங்க மாமனாருக்கு வந்து தோஷம்.
சரி சரி சரி.
அதனால வந்து வீட்டுல எல்லாம் நிறைய விருந்தாளிகள்.
சரி சார் சரி சார். நான் இன்னைக்கு இனிமே அட்டன் பண்ண முடியல. அப்புறம் அட்லீஸ்ட் என்ன ஆகுது, நீங்க என்ன ஒரு ஏதோ ஒரு அவசரத்துக்கு தான் கூப்பிடுறீங்கன்னு தெரியுது. 2 தடவை கூப்பிட்டீங்க. நீங்க டீன் ஆபீஸ்க்கு வந்தீங்கன்னு சொல்லி அப்புறம் சிவா சொன்னாங்க.
ஆமா, நேற்று
போன ஃப்ரைடே.
ஃப்ரைடேமா? ஆமா, போன ஃப்ரைடே வந்து. ஆமா,
அதுதான். அன்னைக்கு தான் கூப்பிட்டுருந்தீங்க.
மேடத்தை டிஸ்கஸ் பண்ணிட்டேன்னு நினைக்கிறேன். உட்காருங்க சார். ஓகே, நான் அதை உங்களுக்கு எக்ஸ்பிளைன் பண்ணிட்டு இருக்கேன்.
சின்ன ஒரு டிஸ்கஷன், ஒரு ஐடியா தோணுச்சு. ஓகே அப்படின்னு பாருங்க. இதை வந்து ஏன் வந்து ஒரு 10 hours ஒர்க் ஷாப் இதுவரையும் நம்ம பண்ணிட்டு எக்ஸ்பீரியன்ஸ்
யாருக்கு பண்ணுறது? அவுட் சைட் பீப்புளுக்கா? ஷாப் பண்ணலாம் சார். ஏதாவது ஒரு வந்து இப்போ கொஞ்சம் காமனாக இருக்க மாதிரி. இப்போ இன்னைக்கு நடத்த போகிறதுன்னா வந்து மோர் ஸ்பெசிஃபிக் ஃபார் கெமிக்கல் இன்ஜினியர்ஸ் அண்டு ஃபுட் ப்ராசஸிங். பட் ஷெல்என்டி ஹீட் எக்ஸ்சேஞ்சர்லாம் இருக்கு இல்லைங்களா, அது வந்து மெக்கானிக்கல் பீப்புள் கூட பண்ணலாம். ஹீட் எக்ஸ்சேஞ்சர் அந்த மாதிரி சில காமன் டாபிக் பண்ணுறது போயிட்டு அதை நம்ம உடனே சொல்லலாம்.
ஒரு 5 days எடுத்துக்கணும். 5 days போகலாம். மேபி 4 எக்ஸ்பெரிமெண்ட் கூட போட்டு ஃபர்ஸ்ட் டே வந்து நம்ம என்ன பண்ணலாம், ஃபர்ஸ்ட் இயர்ஸ் வந்து இன்ட்ரோடக்ஷன் ஆஃப் ஒய் இட் இஸ், அப்புறம் இன்ஸ்டாலேஷன் ஆஃப் தி அப்புறம் ஒரு 4 ஸ்பெசிஃபிக் எக்ஸ்பெரிமெண்ட்ஸ் எடுத்து
அந்த ஒவ்வொரு ஸ்டெப்புக்கும் என்ன மீனிங்னு சொல்லணும்.
அதுக்கு என்ன டீட்டெயிலாக
அது டீட்டெயிலாக சொல்லணும். அது நான் சொல்கிறேன்.
இது வந்து ஒரு சின்ன ஐடியா தோணுச்சு.
சரி சார்.
அதாவது ஆஸ்கிங் பீட்டர் தட் கேன் யூ கோஆர்டினேட் கம்ப்ளீட்லி. பீட்டர் தட் யூ போத் ஆர் ஓகே, எனக்கு ஒன்றும் பிரச்சனை இல்லை. யூ ஆல் செட் வாட் ஓகே, ப்ரொமோஷன் வாங்குறது அப்ரூவல் வாங்குறது எல்லாம் சரி சார். நீங்க கோஆர்டினேட் பண்ணி கொடுக்க முடியுமான்னு கேட்டேன். நான் சார்ட்ட கேட்குறேன்னா, பட் சடன்லி ஐ காட் திஸ் ஐடியா. இஃப் பாசிபிள் சம் ஃபீஸ் கூட, மினிமம் ஃபீஸ் கூட நம்ம வாங்கணும்.
சரி, ஓகே சார்.
டிஸ்கஸ் பண்ணிட்டு மேமையும் சேர்த்துக்கோங்க. நம்ம இவ்வளவு தூரம் செய்யறோம், விதாட் எக்ஸ்பீரியன்ஸ். நம்ம கொஞ்சம் இன்னும் கொஞ்சம் எடுத்து போனோம்னா இன்னும் நம்ம கான்ஃபிடன்ஸ் இன்க்ரீஸ் ஆகும். நீங்க எக்ஸ்பர்ட், நீங்க ஏன் நம்ம வந்து கொஞ்சம் இன்னும் கொஞ்சம் ஒரு எக்ஸ்ட்ரா ஸ்டெப் போகக்கூடாதுன்னு தோணுது.
Okay, sir. Hello. Hello.
Hello.
Yeah, tell me.
Good afternoon, sir. So this is Dr.Gobikrishnan, sir, part of IPE Karunya.
Yes, sir. Yes, sir. Tell me, sir.
Actually, sir, I'm one of students, sir. I'm not the faculty.
Okay, tell me.
Yeah, sir. Actually, we're conducting an online workshop regarding internships, sir. Like,
Sure.
So basically, this program is like for conducted for students, like in order to let them know like how important this internship is, like how it will help them in their career, and like what kind of internship they should do. Generally, yeah. So we're conducting a workshop regarding that. So would you please let your students know that we are conducting certain events?
Okay.
And forward you the details about this internship and what about this workshop.
Okay, sir.
Okay, sir.
Okay, sir.
So, all right, sir. Thank you, sir.
Okay, sir. Thank you. Okay, students, you just listen. Okay. All of you can able to see my screen? Hello, students?
Yes, sir.
Okay, just listen. All of you just listen. Today's experiment is somewhat lengthy. The number of steps, in this experiment will be a little bit more. But you have to understand what is the basic of this experiment. You have to understand. Okay. Today the topic is about the reactor. Okay. We are going to do and this we are going to simulate a reactor. Okay. You know what is a reactor? Reactor means the vessel in which a reaction is carried out. That is called a reactor, isn't it? Okay. Therefore, that is okay. We know that there are different types of the reaction, different classification of the reaction that we know. One classification is the elementary and non-elementary reactions. Elementary, non-elementary means if the rate of the reaction is expressed from just by looking at the stoichiometry itself, then such type of reactions are called elementary reactions. Say for example, if I write like this, okay, say here A plus B gives C plus D. This is okay. Writing this is like this. We call it as equation. The other name for this one is called a stoichiometry. Called stoichiometric equation. Okay. Stoichiometric equation means this will tell what are all the reactants here and what are the product. Okay, and what is the proportion. What proportion the reactants will react and what proportion the product will be formed. In a thermochemical reaction, apart from this, how much amount of heat will be released or how much amount of heat will be absorbed and what is the physical state of the reactants or product. All the reactants or products may be in a single phase. If it is so, then such type of reactions are called the homogeneous reaction. If the reactants or products are in more than one phase, that is called the heterogeneous reactions. Okay. Therefore, these are the informations. Okay. Therefore, these are the information that we can get from any thermochemical reaction. Okay. Then our objective is okay. If you can write directly, but just by looking at the stoichiometry or just by looking at the reaction itself, if you can write the rate expression. The rate expression, see here, minus RA, that is equal to K into concentration of A, concentration of B, I have written. Okay. Therefore, this expression is called rate expression. Okay. Therefore, see here, just by looking at the stoichiometry, I can correlate the rate expression and the reaction. Okay. Rate expression and the reaction. Okay. Now, such type of reactions are called the elementary reaction. Called elementary reaction. Why I am calling this elementary reaction? Because the reactants will react. The steps involved. It's a single step reaction. Okay, there is no multiple steps are involved. Okay, it's a single step, just a single step reaction. That's why it's called the elementary reaction. For the case of a non-elementary reaction, example for the non-elementary reaction is hydrogen plus bromine gives 2HBr. Okay. For this reaction, the rate at which the hydrogen, the HBr forms, little bit HBr forms, is equal to 2.5 moles of H2 divided by 1.2 plus 8.5 concentration of I2. It will come like this. Okay. Therefore, just by looking at the stoichiometry, is there any relation between the stoichiometry? This is called stoichiometry. Is there any relation? Can you guess the relation between these two? What is the stoichiometry and rate expression? You can't guess, isn't it? Okay. But in this case, in the previous case, just by simply looking at the reaction, I can write this one. K, some constant, into concentration of A into concentration of B. Okay. Therefore, this type of reactions are called elementary reaction. Elementary reaction means just by looking at the stoichiometry, we can write the rate expression, one thing. And second thing, it involves only single step only. Only one step will be involved. Okay. But the non-elementary, the meaning is we cannot predict the rate expression just by looking at the stoichiometry itself. We cannot predict. This is because the reaction is not a single step reaction. It involves more than one step. Okay, it's a multi-step reaction. There's the multi-steps, that is called a mechanism. It is called mechanism. Okay, all enzymatic reactions, that is a multi-step reactions. It is an example for the non-elementary reaction. Non-elementary reaction. I think you studied about the Michaelis-Menten reaction. You studied, isn't it? What is the Michaelis-Menten reaction? Hello, anybody? Okay, Michaelis-Menten reaction. What is the Michaelis-Menten reaction? V max. V that is equal to V max into concentration of SA divided by Km plus concentration of S, isn't it? This is the Michaelis-Menten equation, isn't it? Okay. Then the constant here involved of the Km and Vmax. Km and Vmax. Okay. This is an example for the non-elementary reaction. Okay. And second thing, Vm and the Kmax are the constants which we can evaluate with the help of the velocity equation. Okay. Not with the help of by conducting the experiment we can predict. Okay. Therefore, this is a non-elementary reaction. Okay. See here, but what is the enzymatic reaction? How do you represent the enzymatic reaction? Enzyme plus reactant. For the case of enzymatic reaction, the reactant is called substrate. Enzyme plus a substrate is equal to enzyme dot substrate. This is the intermediate. This intermediate again will form enzyme dot product. Then the final product E plus P. Okay. Therefore, this is the steps. Okay. Therefore, this is the stoichiometry. We cannot predict the equation, the V equation. We cannot predict. Okay, this equation, this we cannot predict with the help of this equation, isn't it? Okay. Therefore, it is an example for the non-elementary reaction. Okay. Therefore, elementary and non-elementary reaction is one classification. The another classification is homogeneous and heterogeneous reactions. Homogeneous reaction means all the reactants will be in the single phase. Heterogeneous reaction means the reactant and the product may be in more than one phase. That is, phase I mean, it may be in the solid, liquid, or gas. Okay. Therefore, that is called another classification, heterogeneous reaction. The one more classification is exothermic and endothermic reaction. Exothermic means the heat will be liberated during the course of reaction, and endothermic means the heat will be absorbed during the course of the reaction. Okay, these are some of the classifications. Okay, therefore here reactor means the vessel in which the reaction is carried out is called reactor. Our objective is, okay, in future you will be studying about how to design a reactor. In your 8th semester, 7th semester, you will be studying the next semester. You will be studying about how to design a reactor. Okay. Designing reactor is not that much easy. Okay, don't think that the reactions can be carried out just by taking a vessel and putting all the ingredients and closing that one. You can achieve the required conversion. No, it is not so. Okay, because a lot of things are there to design the reactor. Okay, therefore here what we are going to do, we want to simulate one reactor. We want to simulate. Okay, the next based on the mode of operation, the reactor can be divided into two. One is the batch reactor. One is the batch reactor, and other one is the continuous reactor. Continuous reactor. Okay. Batch reactor means I will take the vessel. I will take the vessel and all the ingredient, that means the reactant will be placed in the vessel and it will be closed. Okay. And the required temperature and pressure will be maintained. Then the reactant will be allowed to react for some certain time. Then at the end of the reaction, the vessel will be opened and the product will be withdrawn. Okay. Therefore, such type of reactions are called batch reactor. Then continuous reactor means the reactor will be continuously fed with the reactant. The reactor will be continuously fed with the reactant, and the product will be continuously withdrawn. And the product, the product will be continuously withdrawn from the reactor. It's a continuous process, okay? And the reactant will stay for some time inside the reactor, and the reactant will be converted into product. Then after that, the product will come out from the reactor. Okay. Therefore, the time spent by the reactant inside the reactor, it is called residence time. It's called residence time. Okay. The residence time is also important. If the reaction velocity is high, the reaction velocity, I mean how long it will take for the conversion of a reactant to the product. How long it takes. The conversion percentage may be 70%, 80%. Sometimes it may be 10%. Okay. Therefore, based on the conversion, how long the reactant has to spend inside the reactor, that is called a residence time. Okay. That also important. And the condition is also important. The condition, I mean the temperature, pressure, that is important. Okay. Then all these things will decide or will affect the conversion. A conversion may be 60%, 70%, or sometimes it may be 100%. Okay, based on the conditions. Okay, okay, now we know the batch reactor and continuous reactor. In the continuous reactor, again, two more classifications are there. One is the continuous stirred tank reactor. Continuous stirred tank reactor. The next one is the plug flow reactor. Plug flow reactor. Okay, continuous stirred tank reactor and plug flow reactor. These are the another two more classification. Okay. Therefore, continuous stirred tank reactor means the reactant and product will be taken in a vessel, and the vessel will be continually stirred with the help of a rotor arrangement. Okay, or stirrer arrangement. Okay. This is to maintain uniform concentration everywhere. If you take any part, any small sample from any part of the vessel, the concentration should be unique. The concentration should be constant. Okay. To maintain that constant, we'll be using some stirrer. Okay. Then such type of reactors are called a continuous stirred tank reactor. Continuous stirred tank reactor. The continuous stirred tank reactors are more suitable for liquid phase reactions. Liquid phase. This is suitable for liquid phase reaction. Liquid phase. Okay. The next comes the plug flow reactor. Okay. The CSTR will be represented like this. Okay. A tank will be there, or a vessel will be there, and the vessel, one stirrer will be kept inside the vessel. That's all. Okay. This is something like that. Okay. This is the schematic representation of a CSTR. Then plug flow reactor means it is a tubular reactor. A tube. Okay. The tube may be a straight one, or it may be a spiral one like this. Okay. Then at the inlet, the reactant will be passed through the reactor, and the outer will be taking the product. Okay. Therefore, with respect to distance of the with respect to the length of the reactor, the concentration of the product will be increasing. At the end, if you see the concentration will be more. Okay. Therefore, this type of reactors are called plug flow reactors. Plug flow reactors are most suitable for the gaseous phase reactions. Okay, doesn't mean that liquid phase reactions cannot be carried out in a plug flow reactor. Liquid phase reactions also can be carried out in plug flow reactor, but the most preferable one is the gaseous phase reactions for the case of plug flow reactor. Okay, all of you can able to understand this classification. Okay, then one more classification is there. One is the ideal reactor and the non-ideal reactor. Ideal and non-ideal. Ideal means, say for example, we will take this. We will go to the next slide. Okay. Now for next, what are the classification we have seen so far? Heterogeneous and homogeneous reactions, elementary and non-elementary reaction, exothermic and exoendothermic reactions. These are the types of the reactions. Okay. The next is the, if you come to the reactor, batch reactors and continuous reactors. Under continuous reactor, again two types are there: continuous stirred tank reactor and a plug flow reactor. Okay. The next is the ideal and non-ideal reactors. Ideal and non-ideal. Ideal and non-ideal reactors. Non-ideal. Okay. Say for example, we will take ideal. We will see what is non-ideal reactor. Okay. So it is an example for the continuous stirred tank reactor, isn't it? CSTR, continuous stirred tank reactor. Good. Then see, I have taken some amount of liquid in a continuous stirred tank reactor, and the reactor is fitted with a stirrer. This one is called a stirrer, isn't it? Okay. Then the reactor will be bigger in size. It may be some maybe 100 cubic meters like that. Okay. And then yeah, I am going to see the concentration at the various zone. Okay. See here, if you start running the stirrer, then what will happen? Then it will form a vortex like this, isn't it? A vortex will be formed like this, isn't it? Okay. Then in this region, if you check the concentration of the reactant or product, that will be uniform. Okay, the concentration will be uniform. And the effect of the stirring, that may not reach this place. Okay, no, these places are called dead zones. These are called dead zones. Okay, therefore our objective is we have to avoid dead zone. But in practical, it is not possible to avoid the dead zone. Some amount of a dead zone will be there. Okay. Therefore, in ideal reactors, we are assuming that there is no dead zone. Okay, that is in ideal reactor. But in reality, it is not so. Therefore, the real reactors are called non-ideal reactors or real reactors. Okay. Therefore, in this case, what we are going to do, first we will develop a equation, model equation for the case of ideal reactors. Then after that, we are going to incorporate some terms to compensate this non-ideality. Okay, the non-ideality is not only because of the dead zone. Sometimes it may be because of the short circuiting. Short circuiting means, since it is a continuous reactor, assume that it's a continuous reactor only. It's not assumption. It's a continuous reactor. Okay. Therefore, what will happen? The reactant will be fed, and the product will be withdrawn here. Good. Okay. Sometimes what will happen? The reactant, without converting into the product, it may short circuit. It may not go to this place. It may not enter into this place. Okay. Then it may leave like this. Okay, without reacting. Okay. Therefore, this process is called short circuiting. Therefore, short circuiting, then dead zone, and one more problem is that is called the dry packing. Okay, that will happen only for the case of a packed reactors. Okay, that will happen. Okay, these are some of the non-ideality. Okay, because of this non-ideality, the concentration or the composition everywhere, that will be different. Okay, in real reactors, it is not possible to eliminate. Therefore, for simplicity, what we are going to do, we will develop a model for the ideal reactors, and that ideal reactors after getting the equation, that will be slightly modified to suit the real reactor. That's what we are going to do. Okay. Therefore, today we are going to deal with the continuous stirred tank reactor. Good. The next here, the another classification of reactors is the reaction is the reversible and non-reversible, irreversible reaction. Reversible and irreversible reaction. Reversible and irreversible reactions. Reversible and irreversible reactions. Okay. Reversible and irreversible reactions. Okay. Then what do you mean by the reversible and irreversible reaction? Let us take this one. Okay. Say here A plus B gives C plus D. Okay. is one type of reaction. The other reaction I will take, S plus H gives E plus F. Okay. Okay. Therefore, two types of reactions I have taken. If you take the first reaction, this is the first reaction, this is the second reaction. For the case of the first reaction, it's a complete conversion of A and B to C and D is possible. For the case of a first reaction, okay, if we give the suitable temperature, pressure, and time, in that case, the first reactant for first reaction A plus B, all A and B can be converted into C and D. It is possible if you supply the sufficient time, and optimum temperature and optimum concentration and optimum pressure, then you can achieve the complete all A and B will be converted into C and D. Okay, therefore the first reaction is called irreversible reaction. The first one, it is called irreversible reaction. Irreversible. Or I can write, okay. This one is the first reaction. The second one is the reversible reaction. Reversible reaction means what will happen? Let us see. Okay, see, I have taken a vessel. In the vessel, I am going to put S and H. For the second reaction, S and H are the reactant, isn't it? Then I am going to keep a suitable temperature and condition, to a suitable temperature, pressure, everything I am going to maintain. Then what will happen? I am going to check what will happen to the product. Okay, then I can write the reactant and the product composition with respect to time, and then I can draw a graph. Okay, let us take a graph like this. The time is in the x-axis and concentration in the y-axis I will take. Okay, therefore initially the concentration of S and H will be the highest, isn't it? Okay, therefore let us take only S alone. Okay, therefore yes, this is the concentration of S. It's high. Then what will happen as the time passes? The concentration of S will be decreasing. It will be decreasing like this, isn't it? Okay, and S also will follow the same path like this. But if you take the product E, this is for the S. All of you can able to see my screen? Hello, can you able to hear my voice, students?
Yes, sir.
Okay, then if you're interested in product, here the product is E. Initially the product will be 0. This is the concentration axis, isn't it? Initially the product will be 0. Then the product concentration will increase. Then it will go to a maximum level. Then after that it will start decreasing. Then after that, it remains constant like this. Okay. Therefore, this is the concentration profile. On the change in concentration with respect to time. That is the concentration profile I will get. But see here, the S will never touch the x-axis. What does it mean? At any time, that means even if you keep infinite amount of the time, then after that time on also some amount of S will be left out. S means what here? Reactant. The reactant will be there. Okay, even if you wait for infinite length of time, the S cannot be converted into the product. Some amount of S will be there. Okay, and H also some amount of H will be there. It never touch the x-axis. If it touches the x-axis, what does it mean? The concentration is going to be 0. Therefore, at the end of the reaction, if I check in the vessel, I can have S, H, E, and F. All will be there. But the concentration of E and F will be more, but the concentration of S and H will be the less. Okay. Therefore, such type of reactions are called reversible reaction. Okay. Today we are going to deal with the irreversible reaction only. Irreversible reaction. Okay. Then next we are going to see what are the factors that will affect the conversion. Our objective is because we want to find how much is the conversion. See here, I have taken certain amount of liquid. Okay, here today we are going to deal with the ethanol, C2H5OH ethanol. Okay, plus acetic acid, CH3COOH acetic acid. Okay, these two will react to give ethyl acetate, CH3COO C2H5 ethyl acetate. This is ethanol and this is acetic acid. This is acetic acid, and this is ethyl acetate. Ethyl acetate is the product here. Ethyl acetate is the product, and some amount of water will also be there. Okay, it is a irreversible reaction we have taken. Irreversible means all reactant will be converted. There is a possibility to convert all the reactions into product unless we maintain the suitable time, temperature, pressure, everything. Okay. Now the reaction is carried out in a CSTR. CSTR. Okay. Therefore, what are the things that affect the conversion? The concentration of these two, that is the concentration of ethanol, concentration of acetic acid. These two will affect the conversion, whatever the product we are getting. Okay. And temperature also will affect, pressure also will affect, and the volume of the reactor also will affect, volume of the reactor. And the type of the reactor also. Type of the reactor, I mean, continuous steady tank reactor or plug flow reactor. Okay. Therefore, type of the reactor, volume of the reactor, temperature, pressure, then the amount of the ethanol and acetic acid substance we have given, and area and other, and one more thing, stoichiometric coefficient. The stoichiometric coefficient means how much stoichiometric coefficient we are going to give. As per the stoichiometry, 1 mole of ethanol can react with 1 mole of acetic acid. Okay, if you give 1 mole of ethanol and 0.5 mole of acetic acid, in that case only I can expect at the maximum 0.5 mole of ethyl acetate only. Okay, this is called stoichiometric ratio or stoichiometric coefficient. Okay, therefore all these things will affect your conversion. Okay, therefore what we are going to do here today, we are going to simulate. Okay, simulation, what we are going to simulate, we want to simulate what would be the output. Output, I mean the conversion. Is it 99%, 80%, something that we don't know. But for input, we are going to give some variable. What are the variables that we are going to give? Amount of ethanol, amount of methanol, amount of ethanol, amount of acetic acid, temperature, pressure, then area, type of the reactor, stoichiometric relations. Okay, all these things, all this input we are going to give. For this set of input, how much output I can expect. Okay, that's called a simulation. That's all. Okay, therefore that can be simulated with the help of this simulation software. That's all. Okay, now see here, we have given a set of conditions, that is the temperature, pressure, everything. Okay, therefore what we can do, the other method, how we can change the variable. So what in the next is simulation, what we can do, we can fix the conversion. Okay, I want to have 80% of conversion, let us take. Okay, for that conversion, what would be the optimum temperature? I can find out. Okay, therefore in that case, I have to leave only the temperature. The rest of the variables I have to give the data. I have to supply the data. Okay, if I supply the data, I can find out that then the 85 conversion can be achieved at what temperature. Okay, then similarly stoichiometric coefficient. Otherwise, to achieve 85% of conversion, what would be the volume of the reactor? That also I can predict. What would be the volume of the reactor? That also I can predict with the help of these one. Okay, therefore, and I will maybe assume that 8 variables are there. Okay, to find out the 7th variable, to find out the outcome of any variable, the rest of the variables you have to provide the values. If you provide the values, then the left out variable I can predict how much would be the left out variable. Okay, that is the meaning of the simulation. Okay, then Sa will tell about how the simulation steps he will share, and all of you have to do your simulation step. And second thing, all you have to use only your laptop, and everybody has to show your output also. You have to show. Okay, before the next week, next Thursday, 1, 2, 3, 4, 4th March. Okay, so far we have seen till today we have seen 4 experiments, isn't it? Therefore, all the 4 experiments you have to take the output and you have to send in the form of a PDF in your Google Classroom, all of you, with your register number and experiment number. Okay, you have to send all of you. Okay, then okay. Sorry for John. Okay, okay. All of you wait for some time. இதனுடைய ரொம்ப இன்ட்ரெஸ்டிங்காக இருக்கும் சார், எஸ்பெஷலி இந்த பார்ட்டு. அது நாங்கள் ஒரு பெரிய ஒரு 2 பேப்பராக படிப்போம்.
நாங்கள் ஏதாவது ஒரு முறை செஞ்சு பார்த்துட்டு உங்கள்கிட்ட வரும்போது
நல்ல ஒரு கண்டினியூட்டி கிடைக்கும்.
நாங்களே செய்யும் போது இது என்னவா ஏதோ ஒரு இமேஜின் பண்ணுவோம், சர்ச் பண்ணுவோம், அதுக்குள்ள நீங்க திரும்ப பேசும்போது அது கேட்கும்போது நல்லா இருக்காது.
சார் I am sharing on the இது பண்ணிருக்கேன்.
Good afternoon. We have heard a very good lecture from our sir. Now let us demonstrate the same with the DWC. Am I audible? Can I get the response from you? Anyone of you?
Yes, sir.
Yeah, thank you.
Yes, sir.
Yeah, thank you. I'm sharing my screen to you. Yeah, so as usual, we go with a DWSIM and we start with the simulation model, new process simulation model. And every time we know initially we have to configure our wizard. So we'll go with compound selection. So as sir has discussed, we are going to take the reaction based on water, based on liquid. Yes, sir.
Students listen here. The compounds which we are going to select is the acetic acid and ethanol. Acetic acid and ethanol as the reactant, water and acid, ethyl acetate as a product.
So we are selecting acetic acid and ethanol. Then water. And then ethyl acetate. Yeah. So every time in our configuration wizard, we select the compounds first of all. As sir discussed, we know the real meaning behind it, what is input and how the reaction is happening also. Okay, now sir has explained that why we have to choose this particular property. Can anybody recall what is the property sir has said? Which property package? Can you say?
NRTL.
Yeah.
NRTL.
Yes, good, correct. NRTL. Okay, so we select that package. Now we follow this unit of measurement as C5. So the configuration is being happened. So now we have to take the material stream. Okay, so let's define material stream. The values in this material stream. So we define the input data here. So we define what we are going to feed. Okay, so we give the name for this material is feed. Okay, So let's define our input data. Here the flash spec is temperature and pressure. Okay. Then we have to change the input data. So we are going to give the values of temperature 70 degree. Okay, the pressure bar we are going to give 1. Then we are going to follow the mass flow as 3600 kg per hour. Okay, so the remaining we follow the same. Then we have to change the compositions. So here we are going to change the ratios of these compounds. So we are going to have the mole fraction of the ethanol is 0.48. Then ethanol is 0.5. Water is 0.02. So it's obvious that the state must be 0. Okay, so we accept this.
I will not some more points here, sir. See, all of you see here. This is the input stream, isn't it? The feed. We are giving material stream for the feed, isn't it? Okay. The temperature we have given 70 degrees, isn't it, sir?
Yes.
70 degrees. Okay. And the mass flow rate is 3,600 kg per hour. Okay. That is both the ethanol and ethanol. Acetic acid. Okay. Put together is 70 kg per hour. And the mole fraction they have given see here 0.48 percentage of what? Acetic acid. 0.5 is the ethanol. And the 0.03 is water. The meaning is some amount of water is coming along with the feed stream, some amount of water. And water will also be produced at the end of the reaction also. Because the water is also one of the products, not only ethyl acetate. Water is also one of the products. Okay, that is the meaning. Okay, one thing. And the ethyl acetate concentration is 0. The meaning is there is no ethyl acetate in the feed stream. Feed stream there is no in the reactant. Sometimes what will happen, some amount of a reactant, product may be associated with the reactants also. In some cases. Okay, and such type of reactions are called autocatalytic reactions. That is the product will itself will act as a catalyst and induce more and more reactant. Okay, that is called autocatalytic reactions. Okay, over here the product ethyl acetate in the feed stream. Okay, okay.
Excuse me, sir.
Yes, ma'am.
For the amount of acetic acid is 0.5, sir.
Okay. Okay.
Acetic acid you consider as 0.48. Yeah, 0.5. Okay.
Acetic acid 0.5, ethanol 0.48, and water 0.02. If you add all these things, that is acetic acid, ethanol, and water, you should come around 1. That is the thing here. Here, if we add all these things, it will be 1. Okay.
And one thing here, for these input values, we are trying what will be output. Okay. So if you can change the values also later, you can verify it. How I have changed here. Ethanol is 0.48, as it is 0.5. That also can be done, but without affecting the nature of the property. Property of such compounds, whatever you take. Okay. So here, the next thing we have to choose the reaction property. So for that, suppose you have your version this particular software version 5.7, you can find chemical this reaction manager on tools, menu tools. Otherwise, you can see the place here. You go to edit and then simulation settings. Alt S. Simulation settings, you just choose. In simulation settings, we are working on reactions, and in these reactions, you take chemical reactions. So Sir already has explained what type of reaction, the chemical reaction is being happened, that is kinetic. Sir? So in this kinetic reaction, we will give the names and so on. So the window will open. So under, so what is the, you just give the name of identification as ethyl acetate. Okay, under identification, enter the name as ethyl acetate. Ethyl acetate. Description. So here, what are we doing actually? That is, you just write it as a description. So that is irreversible reaction for synthesis of ethyl acetate from ethanol and acetic acid. Okay, so this is, we all know, we give this description in this place. Okay, irreversible reaction for synthesis of ethyl acetate from ethanol and acetic acid. Okay, so now we have to select these components and stoichiometry and reaction orders. Okay, so we are going to include all these 4 compounds. Okay, then you just choose the basic component. What is the basic component in this place? That is ethanol. The basic component, what we are choosing here is ethanol. Ethanol. Okay, so we have to we are using here again, yeah, we have to define the stoichiometric coefficient also. So that is the next step. We have to define. So we define ethanol as -1. Sorry, ethanol is -1.
Sir, excuse me, sir. Sir, can you repeat this process again?
All of you listen here. All of the students, can you listen here? See here. Here we have to select all the program include. There is a button, the box is the include. Tick all the boxes. Okay. Then ethanol acetic acid or the reactant. During the course of the reaction, ethanol and acetic acid will, the concentration will decrease. That's why we are putting -1 here. Okay. For the case of water and ethyl acetate, you know, the ethyl acetate, especially ethyl acetate, the concentration of water, the concentration will increase. Because water is one of the product and the ethyl acetate is also one of the product. For that, we have to put 1, that is positive, 1. Okay. Now, you can understand. Number 19, what is the problem? Javakumari. Sharon Javakumari. Tell me what is the problem?
Check whether you understood, please tell. Hope you understood. Okay.
Students, can you able to hear our voice? Students, is it audible? Hello? Students?
Yes, sir.
Now we have, after selecting these components and stoichiometry and reaction orders, we have to verify our equation. So please check the equation.
Okay, sir, I will. At this point, now I will explain one more thing. Okay. See, the stoichiometric coefficient mean, you can write the reaction. Say, for example, H2 plus a half O2 is H2, I can write. Just listen. H2 plus a half O2 is H2O. I can write like this. Okay. So the stoichiometric coefficient for the case of hydrogen is 1. For the case of oxygen is half. Okay. The stoichiometric coefficient mean the coefficient which is present before the element symbol. Okay, that's called stoichiometric coefficient. Okay. Here acetic acid, before acetic acid 1 will be there, and ethanol is also before ethanol 1. It's understood. Okay. That's why we are putting the stoichiometric coefficient as 1, 1. That too, for the case of the reactant, we are putting -1. Therefore, the reactant will be consumed during the course of the reaction. That's why we are putting minus. But for the product, for the case of the product, we are putting +1 because the product will be increasing with the time. Okay. All of you can understand. Okay. So we did not select the component is selected. What about the next component?
The component selected American. Acetic acid, is it right, sir? Yes, sir. So when you select the basic components, please do not forget to choose acetic acid as well as ethanol. We have to verify the equation, what we got here. Please explain the equation.
Yeah, okay. All of you, please pin your screen. All of you, just pin your screen. Then, if you see the screen, you know that this equation CH3COH plus CH3CH2OH gives HOH plus CH3COO C2H5. That is a reaction. Okay. See, what is the coefficient of in each and every reactant and the product? For the acetic acid, the coefficient is 1. And the ethanol also, the coefficient is 1. For water, the coefficient is 1. For acetic acid also, the coefficient is 1. Okay? But the number before that symbol is 1 only. Is it understood? Okay. That's why we are putting
Sir, BZ gadithu. Sir, that is the stoichiometric coefficient. -1 minus.
We are putting stoichiometric coefficient as 1, 1, 1 like that. All of you can understand.
And the equation correct on first another thing. La, the final solve. Okay. So I hope you all understood. Sir already explained why do we get this equation also when he was giving the lecture. Okay, so when the reaction happened and we get the CH3COO C2H5 and additionally the water is added, a little amount of water we get. Sir already explained that. So we can verify that what type of reaction and what is the output here. This equation should be formed correctly. Even I missed to choose this acetic acid as the basic component. So that time there is a mistake we have seen. The CH3COO C2H5 we did not get. So we should add it correctly. So if we do any mistake, it will be changing. Okay. So further, so again this DO column, we have to do some changes. We have to change the values, 1 for ethanol and 1 for acetic acid. 1 for ethanol and 1 for acetic acid. Okay. Then under kinetic reaction parameters, we have to choose bases as molar concentrations. Kinetic reaction parameters. So we have to change phase, Tmin and Tmax. So here base component is acetic acid. So Tmin you just change. Bases as molar fractions. Please change this here under bases, molar fractions. Then give the minimum and maximum value. So we give the minimum value as 300 and maximum value as 2000. So let us do that. Minimum value we take 300 and maximum as 2000. Okay. So here basis is here under kinetic reaction parameters. The basis is molar fractions. Yes.
Excuse me, sir.
Yeah, ma.
Is it molar fraction or is it molar concentration?
Mole fraction.
Sir, molar concentrations. Molar concentrations. Yes, molar concentrations. Molar concentrations. And then phase is liquid.
All of you listen here. In the time select, we have a 300 seconds, isn't it, sir? That is in second time, isn't it? Okay, minimum is 300, maximum is 2000.
2000, sir. In K, sir. In K, it is in K.
Time or temperature? என்ன போட்டிருக்கு?
T mean T max.
Okay. Temperature minimum.
Temperature minimum and temperature
minimum and temperature maximum. Okay, temperature minimum is 300 degrees. 300 degrees means what? 23 degrees Celsius. 23 degrees Celsius. Okay, and the maximum temperature is 2000.
300 to 2000, sir.
300 to 2000. 2000 Kelvin. That is 2000 minus 273. Okay.
Okay, so that is molar concentration only. Molar concentration only. Please do that. Choose basis as molar concentration. Then you choose the phase as liquid. Then T minimum is 300. Temperature minimum and temperature maximum is 2000. Okay, so we have to change direction reactions. Here we have direct reaction and then reverse reaction. So in direct reaction, you assign the value of A. A is 0.005. Okay. You just change it and then click on OK and close chemical reaction window. So these are all the parameters we change and we give the values. So please check once. So once again, I explained this particular window. We have taken this window from edit, and after taking this settings, we have taken reaction. In reaction, we have taken kinetic from the chemical reaction in this point. So once we take add new kinetic reaction, so we give the name as ethyl acetate, and the description is irreversible reaction for synthesis of ethyl acetate from ethanol and acetic acid. Then we select the compounds, and what are all the two basic compounds, ethanol and acetic acid, and we give the stoichiometric coefficients and DO. Okay, so we will get the equation. We can verify by seeing this equation whether we have taken all these compounds and coefficients are correctly. Okay, then we have to give what type of basis we are going to take for the reaction parameter, kinetic reaction parameters. So the basic component is acetic acid, then the basis molar concentrations, phase is liquid, then we have to take T min and T max, and then we will say direct reaction, what is the A value we take in this place, 0.05. Then you just give okay. Okay, so you just close this window also. So I hope you all understand these things. And now
Students, up to step number 18, can you able to follow? Up to step number 18, can you able to follow?
Yes, sir.
Yes, sir.
Okay. Let's start the rest of the steps. He will explain.
okay, so now we are going to choose what is the reactor we are going to use. Okay, so you just look at here, separators, tanks, pressure changers, okay, exchangers, reactors. So in this reactor, we are going to take continuous stir tank reactor. Okay, so you just take this next. Okay, CSTR 01. Okay. So after choosing this, we are going to drag and drop another material stream. Okay, so that is for, why do we take the material stream again? To define what is the product. Okay, so that is the reason why are we going to choose the material stream in this place. Okay, another material stream. Okay, so here we are going to define the names and so on. The object name I am going to keep it as product. Product. Okay, so initially we give feed and we are going to define some of the components of product. So we give the name first, we will see later the output of product. So drag and drop one energy stream and name it as energy now. Okay, so an energy stream. So here we are going to introduce energy. Okay, so energy. Now we are going to give the connections among all these things on this reactor CSTR001. Okay, so CSTR01 under connections. Okay, so in this connections, inlet stream, we have to define what are all the inlet stream, what is the outlet stream, and what is the energy stream. All these three we are going to connect. So inlet stream, that is feed. What is outlet stream? That is product. Here we are going to have only one product, so we choose one product. It is possible that there will be many number of outlet stream. In that cases, we can change it also. So now energy stream is energy. Okay, so this is a reaction. What we are going to do, all these connections we have established. Okay, so under calculation parameters, reaction set, that is default set, we are going to take default set. Then calculation mode. So here we are going to take, there are different types of calculation mode. We are going to take isothermic. Isothermic is our calculation mode. Then we are going to change the reactor volume. That is, we are going to assign 0.14. 0.14. Okay, so now we are going to run the flow sheet. We have run the flow sheet. Okay, so after running the flow sheet, we can see the solutions. Before that, in CSTR01, in property editor window, in result section, property window, in result section, under general, check residence time. So that is 0. Please, we can check like whether we got around 0.033552. In our case, we got 0.03499. Okay, so closer time we got. Okay, suppose we go to conversions. If we go to conversions, we can verify the values. Acetic acid is 99.572, ethanol is 95.5 something. Okay, so here ethanol 99.5476, acetic acid 95.565671. So we have to verify that whether we got this. Okay, so these are all the conversion happened. Now we can check the property tables. We can check the results. Okay, so we can go to insert menu, the property table. What are all the different results we want to have? We can verify it. So in the property table, we have to configure it. So what are all the results we want to have? Okay, so title properties table, So we can change the object type. So title we can change. In properties table, the material stream, change name as results, continuous stirred tank reactor. Okay. Continuous stirred tank reactor. Then object type is material stream. In properties to display, select objects, products, and feed. So under property, this material stream. Okay, so our material stream is feed what we have given. So please select our object type as material stream, that is feed. Okay, so select objects product and feed. Okay, select object product as feed, object product and feed. Okay, so first for each we have to select all the properties. So let us select the objects product and feed. So first we do with feed. So what are all the properties related with feed we need to do? Temperature, pressure, mass flow, molar flow, all these things we have to do. Let us select temperature, pressure, mass flow, molar flow, then liquid phase mixture, volume, liquid phase mixture volumetric fraction, liquid phase mixture volumetric fraction, liquid phase have you got it? Because you find tell it is a very long list, we have to take it very carefully, we should not miss it also. Liquid phase volumetric flow, you just take this. Okay, volumetric flow. Okay, that is enough. Liquid phase mixture volumetric fraction we have to take, not volumetric flow. Okay, volumetric fraction. Volumetric fraction. Liquid phase volumetric fraction.
சரி சார் ஓகே சார் சரி சார் ஓகே சார் ஓகே ரெடி கேண்டிடேட் தானே சரி சார் ஓகே சார் கண்டிப்பா சார் வீட்டுக்கு போயிட்டு நான் போகும் நான் நாளைக்கு ஒரு டைம் சொல்றேன் வர சொல்றேன்
ப்ளீஸ் செக் ஒன்ஸ் ஆல் ஆஃப் யூ
பட் வந்து
Okay, we'll try with the other outputs, other properties. Molar flow mixture ethanol. Molar flow.
Okay, sir. Okay, thank you, sir.
Yeah. Molar flow mixture ethanol, yes. Okay, similarly mass flow mixture ethanol. Mass flow mixture ethanol. Mass flow mixture ethanol. Similarly, molar flow mixture, we have to choose with acetic acid, water, and then is ethyl acetate also. Molar flow mixture. Molar flow mixture, acetic acid. Similarly, molar flow mixture, water also. Ethanol, water, yes. Molar flow mixture, water. And then molar flow, not this molar fraction. Molar flow mixture, water. Okay. So molar flow ethanol, mass flow ethanol. Okay. So mass flow water also mixture. Check whether everywhere we have selected the both. Mass flow mixture acetic acid. Okay, we have selected that also. Yeah. So there are 2, 4, 6, yeah. 1, 2, 4, 6, 8. We need ethanol, water, ethyl acetate also. So molar flow, yeah, molar flow mixture. Yes, it is here. Molar flow mixture ethyl acetate, mass flow methyl acetate. So what are all the other properties? So we have to choose this liquid phase volumetric fraction. Volumetric fraction. Mixture volumetric fraction. Please all of you search one. Suppose you get it, please tell me. It is little difficult. There is no way that like searching and finding. Volumetric flow, liquid phase mixture volumetric fraction, not flow. Fraction. Volumetric fraction. Volumetric fraction. Yes. Volumetric fraction overall liquid. Okay. Yeah, we got it. Volumetric fraction. Any other, please we check once. Volumetric flow, this is, we need volumetric fraction only. Volumetric fraction solid. Okay, we got it. So please note it that everybody, volumetric fraction overall, here we have mentioned as liquid phase mixture volumetric fraction. Liquid phase. So here it is there. Molarity, liquid phase 1, liquid phase 2. Molarity is there. Ethyl acetate, ethyl ethanol. Molarity, liquid phase 1. T. Okay. So you just choose this volumetric fraction, overall liquid we have taken. Let's see the result. Later you just try, it should be there itself. Phase flow of volumetric fraction also. Liquid phase volumetric fraction. Liquid phase mixture volumetric fraction. But here it is not mixture again. Overall fluid only it shows. You have to see in the place of mixture. Volumetric flow. Molecular, specific, molar, thermal conductivity, mixture, vapor. So we'll find out now with this value. Later I'll also will check and tell. Otherwise, if you could find out also, please share. So simply we have to find out among this many numbers, we have to find out. Okay. So similarly, we define the product. Now I said how we are defining the properties, whatever required for feed, and then now product. So temperature, pressure, mass flow, molar flow, okay, everything the same thing, because you just look at the type what we are doing. Double click on master property table, okay, and choose the name as results, continuous stir tank reactor, object type is material stream, yes. In properties to display objects, product, and we have to select two products and feed. So we will select all these properties, okay. So for product also we have to choose all these properties, okay. So we have to choose temperature, pressure, mass flow, molar flow we have done. Then we have to do liquid phase mixture volumetric fraction. Liquid phase, that is actually we have chosen as the same thing here also we choose. Volumetric fraction or liquid flow. Mixture, liquid flow. Here we have taken overall liquid. Okay. So now the other properties, mass, molar flow, mixture, ethanol. Molar flow, mixture, ethanol, acetic acid. Okay, mass flow, mixture. After acetic acid, we get ethanol. So molar flow and mass flow mixture ethanol. Similarly, we take molar flow and mass flow mixture with water. Then again, ethyl acetate also, molar flow and mass flow mixture, ethyl acetate. Okay, so we'll get the table. What are all the feeds we have done? What are all the outputs, the product outputs? Okay, so here you can see the product outputs. Okay, so the product output of the product, the temperature is 70 degrees C. So in feed whatever we have done, then pressure, mass flow, molar flow. So what is molar flow mixture? Okay, then mass flow, molar flow. So everything we will get here. So this is the output, we can get table form. And sir has already explained to you the conversion. Mainly sir said we are going to verify the conversion. That is in this table on CSTR01. Here I think I'm moving the cursor. You can see the acetic acid must be 99 and ethanol must be 95. So here itself we can verify it, whether is it correct or not. Okay. So if you have any doubt, you can ask. So with this, the steps are over. So I share this with you. Already I have shared in your Google Classroom. You can check that. Sir, finish பண்ணிட்டேன். வந்திருக்குங்க சார். செக் பண்ணுங்க.
அவுட்புட் என்ன temperature, pressure, mass flow, molar flow rate.
இது ஃபீட் பண்ணதுங்க சார். ஃபீட் ஃபர்ஸ்ட்
how much of a kg, molar flow, kg mole per hour, molar flow, mixture,
ethanol.
For ethanol. தனித்தனியா கொடுக்குறது. இது ரெண்டு வருது. molar flow, mixture, ethanol, molar flow, mixture, ethanol, molar flow.
So molar flow and mass flow.
Oh, molar flow and mass flow. Okay. So,
one is molar flow, another one is
flow. Mass fraction next. mass fraction.
That must be mass flows. நான் தப்பா choose பண்ணிருக்கேன். Mass fraction கிடைச்சிருக்கு நமக்கு. Okay.
இல்ல அது நீங்க அப்புறம் molar flow.
You can suppose you want your answer as mass fraction, please choose it. Here, as per our procedure, we are following mass flow only. I have made the selection as mass fraction, so it has come. Okay, but here, as per the procedure, we study only flow only. That is, you can verify. Here you can see in the output I have taken correctly. So whatever you select the values, whatever it is calculated, it will show to you. Sir, is it correct, sir?
நம்ம என்ன செலக்ட் பண்ணாலும்
அது என்ன அந்த வேல்யூவோ அது கொடுத்துருது.
ஆமா என்ன தெரியுமா வரும், நீங்க வந்து இதுல மெயின் என்னன்னு கேட்டா ரெண்டு திங் கேட்டா மாஸ் ஃப்ளோ இருக்கு இல்லையா, அது 3600 கொடுத்துருக்கோம். அப்புறம் என்ன காம்பவுண்ட்னு கொடுத்துருக்கோம். அப்புறம் அதோட ஃபிராக்ஷன் கொடுத்துருக்கோம் 0.48, 0.02, 0.5. அதையும் இதையும் கம்பேர் பண்ணி மீதி எல்லாமே வந்துடும். செலக்டே பண்ண வேண்டியது இல்லை. நீங்க செலக்ட் பண்ணா வேல்யூ வரும் கரெக்ட். இருந்தாலும் அதை பேஸ் பண்ணி மோலார் ஃப்ளோ, மாஸ் ஃபிராக்ஷன், மோலார் ஃபிராக்ஷன் எவ்ரிதிங் அந்த டீடைல்ஸ் பேஸ் பண்ணியே வந்துடும்.
அதை பேஸ் பண்ணி தான் நமக்கு கிடைக்குது. So now you can do. So please start to do. If you have any doubt, please ask. So you can take the procedure from your Google Classroom. It is little longer compared with the other procedures what we have done. So some of the inputs whatever we give, and here even the output parameters whatever we want to have on this table, the results. So when we choose a property, we have to be very careful and we have to search and take it.
அட்டெண்டன்ஸ் எடுத்து விட்டுருலாம் சார், 1.5 மணி நேரம் ஆச்சு. மூன்றரை சார், அதை பற்றி பண்ணி Students, students, can you able to hear my voice? Hello?
Yes, sir.
Okay, okay, all of you, okay. Give your attendance. என்னது
வேல்யூ தப்பா வருதுன்னு சொன்னாங்க. அது நாங்க ரன் பண்ணி பார்த்துட்டு ஒரு சில டைம் அப்படிதான் வந்தது. அப்புறம் ஏதோ ஒரு பேக்கேஜ் ப்ராப்பரா எடுக்க மாட்டேங்குது. அதுக்கப்புறம் திரும்ப ரன் பண்ணப்ப அந்த வேல்யூ கரெக்ட், அந்த கன்வர்ஷன் வந்து ப்ராப்பரா வரல, ஏதோ ஒரு மிஸ்டேக் வருது. அப்புறம் திரும்ப நாங்க ரன் பண்ணி பார்த்தப்போ கரெக்டா வந்துச்சு. இதே மாதிரி 0.3954 தான் வேல்யூ வந்துச்சு, 0.3795. ஏதோ ஒரு சின்ன எரர் ஆகுது. அது பார்த்தா ஹோல் திங் கரெக்ட்னு காமிக்குது, ப்ளூவா காமிக்குது. அந்த கன்வர்ஷன் வேல்யூ மட்டும் லைட்டா மாறுது. அது
Students, so here in chat box there are few comments about the output, what we get it as conversion. We get acetic acid is 0.3795, 0.3954 and so on, like, okay, for ethanol. So it happens, please check your ratios of the compound what we have included, 0.5, 0.48, 0.02. Sometime when you click enter, it won't be correctly the ratios or whatever input values we have given. Even I remember once I do this experiment before coming to our class, I got the same answer. Okay, then later I checked in input, I have done a small mistake and I corrected in this ratio only, I think. Okay, and another way, sometime when you run, the computer will be missing some of the packages to call, in the backend packages to call. In such case also the errors will come. Okay, so we have to be very careful. Anne and Sharon, other friends, if you get this value, please do it again, surely we'll get the answer. Okay, when we tried also, we got a value like this. Okay, but the correct answer is what it is given in the procedure as well as what I have shown to you. Okay.
Sir, excuse me, sir.
Yeah.
Sir, in the basic component, should we have to select only ethanol or should we have to select both ethanol and
both are basic components. Both are basic components. I missed to choose.
Okay,
Okay.
okay, sir.
Yeah.
Students, give your attendance. Number 45. 45.
Present, sir. Present, sir.
46.
Present, sir.
47.
Present, sir.
48.
Present, sir.
49.
Present, sir.
50.
Present, sir.
51.
Present, sir.
52.
Present, sir.
53.
Present, sir.
54.
Present, sir.
55.
Present, sir.
56.
Present, sir.
57.
Present, sir.
58.
Present, sir.
59.
Present, sir.
60.
Present, sir.
61.
Present, sir.
62. 62. Absent. 63.
Present, sir.
65. 65. Absent.
So he got disconnected, sir.
67.
Present, sir.
68.
Present, sir.
69.
Present, sir.
70.
Present, sir.
71.
Present, sir.
72.
Present, sir.
73.
Present, sir.
74.
Present, sir.
75.
Present, sir.
76.
Present, sir.
77.
Present, sir.
78.
Present, sir.
79.
Present, sir.
80. 80. Absent. 81.
So chat box lo potukan, sir.
82.
Present, sir.
84.
Present, sir.
85.
Present, sir.
86.
Present, sir.
88.
Present, sir.
89.
Present, sir.
90.
Present, sir.
91.
Present, sir.
92. 92. Absent. Okay. All of you can leave. You have to submit your output. You have, for all the 4 experiments, you have to take the output in the form of a PDF file, and the title of your file should be your register number followed by the experiment number. 4 different file, PDF file you have to upload in Google Classroom. Okay. All of you, thank you.
Excuse me, sir.
Yes, ma'am.
So, the last experiment, we were not given the correct procedure. So, you said you would give it.
Which one? This procedure or the shell and tube heat exchanger?
The last experiment, sir.
Shell and tube heat exchanger. Okay, I will give you the procedure. Otherwise, you get the procedure from other batch. You can get the procedure. They will be handled. Okay.
Yes, sir, we got it from that only, but we couldn't do it correctly. Then you said you would provide the procedure.
Sure, okay. Tomorrow you just remind me. I will send you the correct procedure.
Sir, excuse me, sir.
Yes, ma'am.
Sir, number 80 is present, sir. Present, sir.
Who is number 80?
Sir, Shirley, sir. She got disconnected due to network issues.
Yeah, okay. All of you can leave. Okay. Thank you.
Thank you, sir.
Thank you, sir.
Number 4, 4th experiment.